Saying thank you and please is costing us millions in the electricity bills. This is what the CEO of OpenAI, the company behind ChatGPT, said in a recent interview. Well, I would say that being polite is a pretty wise move if you think about any future uprising of the robots. But really, why is that? You see, whenever we ask a question from ChatGPT, there would be millions of simple math operations like addition and multiplication running in the background instantly. And this speed consumes so much energy that we even require dedicated power plants just to keep the systems running. At UCLA, my thesis focuses on solutions to reduce this energy consumption by rethinking how we perform these fundamental operations, which happen to be the backbone of AI computing. Well, we have found a solution. Interestingly, our multiplication approach is based on an idea from 70 years ago. We use a controllable capacitor to do the job. And in case you're wondering, a capacitor is a small electronic part that can store charge. Here is how it works. Imagine the first signal loads some charge onto the capacitor, and the second one that we want to multiply, like a hand squeezing or stretching the capacitor, changes how much energy it can hold. The interaction of these two signals would result in a charge on the capacitor that reflects the product of the two signals. Now for the addition, we figured that interestingly, if we incorporate a bunch of these multiplying capacitors in a network, their individual charge would add up automatically and the addition happens naturally. Pretty much like my favorite childhood game where we roll a cart around the yard and along the way each kid would hop in for a ride. Here as well, each capacitor adds its own passenger, its own charge to the traveling wave, and at the very last stop, we sense the wave and extract the result. In our test, using this method, we demonstrated around 10 times less energy consumption compared to the state of the art, and which is equivalent to saving a lot of resources and, of course, money. The strength of this idea comes from the fact that we are using capacitors that store charge without needing to stay plugged in. And also, we are leveraging the natural behavior of waves to do the addition. The idea itself also is purely grounded in physics, and all of this is happening on a small chip. So here the takeaway, I think, is that not all problems require complicated solutions. What do you think? And by the way, my name is Amir. Thank you very much.